Why would you fill up your kitchen with all the possible gadgets if you're just going to have takeout every night? Sounds like a bit of a waste. Let's dig and try to figure out why this happens. Not just in our kitchens, but also in our code. Today we're going to explore the code smell Refused Bequest. We're going to use the analogy of a kitchen full of gadgets, including a spaghetti spoon that wants to fork your process. Talk about getting tangled in your code. Just like every gadget in a kitchen has a function. In object-oriented programming, classes inherit methods and properties from parent classes. When a subclass ignores most of these inherited features, not just one or two, well, imagine your kitchen filled with gadgets, blenders, mixers, and more. They're all ready to be used, ready to appear on a reality show called America's Got Appliances, where the only talent is being slightly underutilized. If you find yourself not using the tools provided by the superclass, why are you inheriting them in the first place? It's crucial to assess if inheritance is the best way to do things. If you're not going to use all those inherited methods, maybe a different design pattern like composition could be cleaner, like buying a phone so you can just have a flashlight. Ignoring inherited tools isn't just a waste of resources, but it also confuses future users or developers who expect these tools to be used. This will eventually take you to code that's harder to maintain and extend. Just like unused kitchen gadgets, unused inherited features can clutter and complicate your code without any point. Picture your code wondering if it'll ever get to use that advanced sorting algorithm inherited from the superclass. A wise man once said that the best way to avoid a trap is to know of its existence. So how do you recognize the existence of Refused Bequest in your code base? 6 go-to methods. Inspect subclasses for inherited methods that are never called. If a class consistently ignores methods or properties provided by the parent class, this is a strong indicator of Refused Bequest. Let's take a look at this. So here we have our parent class. It has a whole bunch of properties and it implements a whole bunch of methods. If you look at our coffee appliance gadget, the inheritance makes sense, but the garlic grinder doesn't even work on electricity. It has no timer, it has no settings to adjust, it has no display. It's going to have a lot of unused inherited methods that are never going to get called. If you find that a subclass has overridden inherited methods, but it only provides empty or very trivial implementations, for example, just call super.method or parent or whatever your syntax is, and it doesn't add any new functionality, this can be a sign of Refused Bequest. The class is fulfilling the contract of inheritance, but it's not using the behavior of the superclass. Look for patterns where only one or a small subset of the inherited features are used by the subclass, and the rest are just ignored or overridden without substantial modification. Disuse is a good indicator that inheritance is not the most appropriate relationship in this particular case, which is exactly what we have here. All these methods would not be used. They would be blank. They would return 0, or they would just return an error. That's a perfect example. See if the subclass and the superclass share a conceptual relationship. In cases where the subclass doesn't seem to conceptually align with the superclass, for example, you have a subclass garlic grinder and it's inheriting from the superclass kitchen appliance gadget. It might be inheriting properties and methods that have no real use for suggesting a misapplication of inheritance. Exactly what we have in this particular case. Notice if the subclass could function just as well or better without inheriting from the superclass. If decoupling the two would lead to more straightforward and less complex code, it might indicate that the inheritance structure is not beneficial. If I remove this inheritance, nothing changes for my class. I should be inheriting all of those methods for the grinder in the first place. Nothing from the parent class can be used. Or maybe almost nothing. Finally, regular code reviews can help catch Refused Bequest early. Feedback from other developers might point out unnecessary inheritance or suggest other design patterns, like composition over inheritance. It's all fine and dandy when you can find Refused Bequest, but how do you fix it? Better yet, what are the strategies for doing it right the first time. I have 3 go-to strategies in order of general preference. Of course, use your judgment because it depends on the context. The first would be composition. Instead of inheriting everything from a parent class, a class can include instances of other classes that provide the necessary functionality. This is basically composition, and it follows the design principle of favor composition over inheritance. With composition, you have more control over which aspects of another class to use, and you can change the composed objects at runtime, so you can essentially have a more flexible and dynamic behavior. By the way, that's basically the strategy pattern. Other options you can use are mixing classes, service classes, or delegation. There's no point in your class having all that functionality if it doesn't use it. If you need the functionality, implement it in another class and simply call that class. For example here, this is exactly what we have with those properties. They essentially have a reference to external classes. You can write code that's going to call those and the methods or properties of those objects if you need to. Another method is the interface implementation. If you use interface, it can be a great alternative to inheritance. Interfaces will let you define methods that have to be implemented by any class that adopts the interface without forcing you in how the method should be implemented. This will give you a clear contract for what class can do without forcing the inherited class to take on any actual code or property implementation that you might not need. Why is this strategy number 2 and not number 1? Because it means writing a lot of code, which, if not done right, may end up as duplicate code. I would consider composition first, but that's a personal preference. Again, it depends on the context. The third method is the decorator pattern. Without going into too much detail, the decorator pattern allows behavior to be added to individual objects, either statically or dynamically, without affecting the behavior of other objects from the same class. This particular pattern is really useful for modifying the functionality of a class without changing the class itself, so you avoid unnecessary inheritance. If inheritance is essential, refactor your class to ensure all inherited properties are necessary and used. This might mean using the appliances in your kitchen to fit the specific jobs you're actually doing, or sell them all and use the money to finance the phone you'll use to call for takeout. Our sample class here clearly shows a lot of methods and possibly also properties that are absolutely not needed in the case of our manual garlic grinder gadget, or maybe it just uses a couple. And this is where the analogy comes from. You have a kitchen full of gadgets, but you're not using any of them. The gadgets are the methods. So you need to refactor this and simplify the inheritance. Regularly review your classes for unused inherited properties and methods, like a hawk scanning for its next meal. Consider using interfaces or abstract classes to define essential methods that must be implemented. Common issues might include some subclasses that have grown non-functional because of ignored inheritance. To fix this, make sure you have regular code reviews and you have also refactoring sessions to align the subclass usage with the inheritance. We've seen how neglecting the resources we have can lead to inefficiency, whether in a kitchen or in the code. Using inheritance wisely is key to maintaining a clean and effective code base. Go review your code base for any signs of refused bequest. Tweak, refactor, and optimize. When you find a function that's not being used, refactor it to put it out of its misery. Got an idea for a future video? Drop it in the comments. I read all of them because clearly I'm preparing to write a thesis on the art of the cliffhanger.